take a look at a rice problem that uses the reaction C2H4 going into equilibrium with CH3 and CH. All right, we should note that all of these are labeled as gaseous, so it doesn't matter whether we are doing KP or KC, everything can go in. So keep in mind, though, that if one of them was solid, we would simply draw a big X underneath it and just completely ignore it and just run numbers on everything else. All right, if a liquid or solid, or if it's KP and it's aqueous, because KP can't take aqueous, then it just makes the problem shorter. It's not like you have to overthink anything. You just flat out ignore a component of the reaction. Now, it flat out gives us a starting concentration here, which is nice. We don't have to do any thinking. All right, it says that we start with 0.8 molar, and we know that the products always start at 0. The reactants go down while the products go up. I'm supposed to bring down coefficients, but there aren't any, so let's just assign the x's. I plus C equals E, so let's combine those rows, and we'll get 0.8 minus X along with a couple of X's. My unsubstituted equation for Kc, which again, luckily is, I'm sorry, it's going to give us Kc. Well, let's, Kc is going to be the extra given information. There's always a tidbit that it gives us. So it's giving us K, which means quadratic, so that's a bummer. But let's set up the unsubstituted real quick. So we're going to go CH3 and CH, which are the products, over C2H4, which is the reactant. There's no exponents because there's no coefficients. It gives me a Kc value in the problem. It says that Kc is equal to 0.05. So I can sub in that value as being 0.05. All right. And then we can sub in these guys, which is going to be an X times X is going to be X squared over the C2H4, which is 0.8 minus X. All right, so now we need to solve, because remember, we want to know the equilibrium concentrations. Actually, it's specifically asking for the CH, which is one of the products, so that's what we want to find. So we need to locate that X there. So we've got to solve for it. I'm going to go ahead and put the K over 1 and cross multiply. When I do that, all right, we're going to end up with, let's go this direction first, all right? So I'm going to distribute in, so 0.05 times 0.8 is going to give me 0.040, and then 0.05 times X is going to give me 0.050X. Equals 1 times X, which I already simplified that, but it's X squared. Here's where my quadratic begins to form. And if you remember, I really need it to be a 0 equals expression. All right, so I need to bring everything to one side of the equality, but I never want the X squared to go negative, which it would if I brought it over here, because I'd have to subtract. So I'm going to bring all this stuff over to this side. By subtracting 0.04, it'll make it negative. And by adding 0.05, it'll make it positive over here. So the expression comes out to be X squared plus 0.050X minus 0.040. And here's where we want to cheat on our calculator, not our calendar. That would be weird. So that we don't have to solve the quadratic. So let's take a look at, remember the buttons to push to do that. So I'm going to go math, scroll down to solver, which is the very bottom one, and hit enter. All right, find a better way to show you this. There we go. All right, 0 equals, so I'm going to go alpha in the button that'll give me an x. Then I'm going to go to the x squared button that'll make it squared. Plus, and look, I'm just copying this right here, right? 0.05 x, so alpha and another x, minus 0.04. So there's the equation that we're wanting to solve. Remember, we need to put in a guess here. I always choose 2. And then we want to solve. Now, my solve on this calculator is the alpha function of the enter key. So I'm going to go alpha solve, and it's going to spit out x. All right? And it's right where the blinking cursor is. So x to the right sig figs is going to be 0.18 molar. Now, remember what it wants us to find. It wants us to find the concentration of CH. All right, so CH, luckily, is just the X by itself, because had it wanted the concentration of this at equilibrium, we would have had to go 0.8 minus 0.18. But that's not what it wants. It just wants X. So this is the answer.